This is mathheals.com, where you'll find more links to math and computer science YouTube videos. Let's take a look at exponential and logarithmic functions. And I've kind of, for this particular lesson, kind of picked in certain topics to cover that I think would be beneficial for you in Calculus 1. We have our equality of exponents. And what that says, if b to the p power is equal to b to the q power, then p is equal to q. Typically, the b's are numbers. Like you'll have 2 to a power equal 2 to a power. And if you have that, then you can set the exponents equal to each other. Now, p and q can pretty well represent anything. Let's take a look at a problem with this. Got 2 to the x is equal to 16. And we start with the larger number, which is 16, and we try to rewrite it as the other number to a power. Well, the other number is a 2, so we try to rewrite 16 as 2 to a power. Well, that'd be 2 to the 4th. Now, since they're both 2 to a power, I can set the exponents equal to each other. And this is already solved for x, so we're done with that problem. Our third problem, we've got 3 to the x minus 5 is equal to 27. Now again, we'll start with the larger number, which is 27, and try to rewrite it as the other number to a power. Well, the other number is a 3, so we try to rewrite it as 3 to a power. Well, 27 is 3 to the 3rd. Now, since we were able to write both of them as 3 to a power, we can drop the 3's, cross them off, and set the exponents equal to each other. So we got x minus 5 is equal to 3. And then we want to solve this, so we take the negative 5 over, becomes a positive 5, and we get x is equal to 8. Now here we got 1/4 to the 5x minus 1 equals 8. Now if I start with the larger number 8, probably not very easy to rewrite that as 1/4 to a power. So that doesn't work well. And if I start with a smaller number, I probably can't rewrite this as 8 to a power very well. But I notice that 4 is 2 squared. So I go ahead and rewrite that. And 8 is 2 to the 3rd. Well, that's closer. They're both 2 to a power, but this is one on the left is trapped in the denominator. Remember, we got a property from intermediate algebra. If you move something opposite in the fraction, the sign of the exponent changes. So if we take 2 to the 2nd power up on top, it becomes 2 to the negative 2. Equals 2 to the 3rd. And we're a lot closer. We're raising one exponent to another exponent. When you do that, you multiply the exponents together. So this becomes 2. Negative 2 times 5x gives us negative 10x. And negative 2 times negative 1 gives us a positive 2. And this is what we wanted to achieve. We wanted to get 2 to a power equal 2 to a power, or any number, that is. So now we can set the exponents equal to each other. So I got negative 10x plus 2 equal to 3. I want to solve for x, so I take the 2 over. It becomes a negative 2. So we got negative 10x is equal to 1. And we're going to go ahead and divide both sides by negative 10. And we get x is equal to negative 1/10. And that's our answer. Now we got the power principle, and this basically says if you got something equal to something else, that's pretty vague, then what you can do is you can take both sides to the same power. So I'll say to the n power. So we take p to the n power and q to the n power. Now specifically, if we got it in fraction form. So if you got fractional exponents, that's also called a rational exponent. So if you have p to the a over b power equal to q, we can take both sides to the reciprocal of this. So this would be both sides to the b over a power. So this becomes p is equal to q over b to the a. Now if a is even, put a plus or minus before q. Now when you raise both sides to a power, you have to check your answers. You'll get the right answers, but sometimes you get false answers. So let's take a look at our first problem here. So we got x to the 3/4 power equals 27. Excuse me. Now we're solving for x, and we got a fractional power here. So what I can do is I can take both sides to power equal to the reciprocal of 3/4. So I'm going to take both sides to the 4 over 3 power. Now the number up on top here in fraction form is odd. So no plus or minus. We don't need to worry about putting a plus or minus on the other side. Now here these 4's cancel, the 3's cancel, and we're left with x. And if you got a number to a fractional power, to a rational exponent, you can take the number that's on top, numerator, and put it on the outside of the parentheses. So we can take the 4th power and put it on the outside of the parentheses. Reason why we do that is we can put this into radical form now. This is the cube root of 27. Basically, whatever number's in your denominator, the 3 is what goes in this slot right here. That's called your index. And whatever power is on top is what goes inside here. Oops. 27 is 3 times 3 times 3, which works out well because our index is 3, so we're looking for a set of 3 of something. We have 3 3s, so they come out as a single 3. So we got x is equal to 3 to the 4th. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So that'd be your answer. We'd have to check it, but it actually does work. Because remember, when you raise both sides to a power, you have to check your answers. Now here we got x to the 2/3 is equal to 16. And we got this to a fractional power, so I'm going to raise both sides the reciprocal of that. So I got x to the 2/3, and I'll raise it to the 3/2 power. And I got 16 to the 3/2 power. So we're raising both sides of the 3/2 power. Now, the number on top here is even. So we're going to put a plus or minus on the other side. So we have to have a plus or minus here. Well, 2's cancel, 3's cancel, we got x is equal to plus or minus. And we'll do the same little trick we did over here. This becomes 16 to the 1/2 power, raise the 3rd power. Take the number up on top in our numerator and put it on the outside of the parentheses. The reason we do that, 16 to the 1/2 power is the square root of 16, which gives us 4. So we got 4 to the 3rd, which gives us plus or minus 64. 4 times 4 is 16, times another 4 is 64. And if I were to put both of those in there, both of those check. So we're fine there. Let me save this page. Okay, so we got... This is exponential and logarithmic functions, page 01.pdf. Now we got a general technique to solve exponential equations. Exponential equations, you got a variable in the exponent. So exponential equations. First step. Get the part with the variable in the exponent. By itself. The 180 numbers in front of it, the 180 numbers after it. Step 2, take the natural log of both sides. Take ln of both sides. Step 3, use properties of logs to get the variable out of the exponent. And this should be all review. You should have saw this in college algebra. And then step 4, solve for x. So we're not going to go through a huge amount of examples. Okay, so let's look at this one. So we've got e to the x minus 2 equals 3. Our first step, get the part of the variable in the exponent by itself. Well, the part of the variable in the exponent is e to the x minus 2, and it's by itself. There's no numbers in front of it, there's no numbers after it. Step 2, take natural log of both sides. So we've got natural log of e to the x minus 2 equals natural log of 3. Step 3, use properties laws to get the variable out of the exponent. Well, remember when you have natural log and e, they cancel each other away. So we got x minus 2 equals natural log of 3. And then step 4, solve for x. We'll take negative 2 over, and we get x is equal to 2 plus natural log of 3. And that's our answer. Now let's review our 3 main log properties. Our first one says we have log of something, log of m, plus log of something else, log n, addition, addition becomes multiplication. So this is m times n, log m times n. Our second one, we have log m minus log n. Well, subtraction becomes division. So we have log m divided by n. And if you have p log m, typically p represents a number. Well, you can take that and put it as your power. So you have log m to the p power. Now, these are written in terms of just log, which is base 10. But they apply no matter what your base is. Specifically, the problems we're going to look at are natural log, ln. So let's look at our first problem. Got natural log of 3x over y. Well, if I look at the main thing that's happening here, it's division. We got something up on top divided by something on the bottom. So you come over here, division from property 2 becomes subtraction. So this becomes natural log of 3x minus natural log of y. Now our goal is to get the xy by itself, like this, or if we have a number to get it by itself. So this log we're done with. But if we look at our first one, we have 3 times x. Well, multiplication from property 1 becomes addition. So this becomes natural log of 3 plus natural log of x minus natural log of y. And that's our answer. Let's look at number 8. We got natural log of x squared y to the third over z. And we have to look at the main thing that's happening here. We got something up on top divided by something on the bottom. So it's division. Well, division becomes subtraction. So this is natural log of x squared y to the third minus natural log of z. Now z is by itself, so we're done with that one. This first parentheses, x squared times y to the third. Well, that's multiplication. Multiplication becomes addition. So this is natural log of x squared plus natural log of y to the third minus natural log of z. And again, we'd like to get a single x here and a single y here, and we got a property that says you can take your power and put it out in front of your log. So this becomes 2 natural log of x plus 3 natural log of y minus natural log of z. And that's our answer. We'll find in calculus some of the problems leaving it in this form would be very difficult to work. But by rewriting it in this form is very simple. Number 9. We've got natural log of the fifth root of x minus 7. Same instructions, expanded. Whenever we have radicals, when we're working with logs, we want to rewrite them in fractional power form, rational exponents. So this becomes the 1/5 power. Whatever number is in this little slot, that's your index, that goes in your denominator. Whatever power is inside, if there is one, goes on top. And if there isn't one, you just put a 1. Well, here we got something to a power. We can take the power and put it out in front. So that becomes 1/5 natural log of x minus 7. Now we'd like to have the x by itself and a 7 by itself, but there's no property that allows us to split that apart. So that's our answer. Let me save that page. Let's look at our next problem. So we've got natural log of the square root of x plus 3 over x squared. And again, we want to expand it. We don't want radicals, so we'll rewrite this as x plus 3 over x squared to the 1/2 power. Now this is a commonly missed one when I ask people what's the main thing happening here. They say division. But it's not. We got something to a power. Specifically it's a fraction to a power. But the main thing is we're taking everything to the 1/2 power. So first thing I'll do is take the 1/2 and put it out in front. Now as we rewrite the problem from here on out into separate logs, that 1/2 has to go out in front of every log. So now if I look what's inside the parentheses, the main thing that's happening is division. So division becomes subtraction. So we got 1/2 natural log of x plus 3 minus 1/2 natural log of x squared. Now x plus 3 we can't break down any, but the x squared, I can take that power and put it out in front. So this becomes 1/2 natural log of x plus 3 minus 1/2 times 2 natural log of x, which gives us 1/2 natural log of x plus 3. 1/2 times 2 drops away. That gives you 1. So we got minus natural log of x. And that's our answer. Now next problem goes the other direction. They give us separate logs and want us to merge them into a single log. So we got natural log of x plus natural log of y. And addition becomes multiplication. So this is natural log of x times y. And that's our answer. Here we got 5 natural log of x minus 7 natural log of y plus 3 natural log of z. Now, my properties are on the previous page, but my first two, the addition, subtraction, the only time you can use those is when you don't have a number in front of your log. It has to just be the log of something. So first thing I'm going to do here is take these numbers that are in front of my logs and put them as my power. So this becomes natural log of x to the 5th minus natural log of y to the 7th plus natural log of z to the 3rd. And then you pretty well just follow your order of operations. We'll do it from left to right. So if I look at the first two logs here, we got log of x to the 5th minus natural log of y to the 7th. Well, subtraction becomes division, so this becomes natural log of x to the fifth over y to the seventh, plus natural log of z to the third. Well, now we got log of something plus log of something. Addition becomes multiplication, so this becomes natural log of x to the fifth, z to the third, over y to the seventh. I went ahead and put the z to the third up on top of the fraction. With multiplication, you can do that. Number 13. Got 1/5, and then bracket 3 natural log of x minus 2 plus 5 natural log of x minus 4, close bracket. Okay, we follow our order operations basically, and order of operations says you do what's inside the parentheses, do what's inside the brackets. Well, we got parentheses, but there's nothing to do inside of those, so I do what's inside the brackets. Well, before I can do any of my log properties, again, you cannot have any numbers in front of your logs, so that's the first thing I'll do. I'm going to take the 3 and put it as my power, so I have natural log of x minus 2 to the third power. And I'll take the 5 and put as my power. So that gives me natural log of x minus 4 to the fifth power. Now looking at what's inside the brackets, we have log of something plus log of something. Addition becomes multiplication. So this becomes 1/5 natural log of x minus 2 to the third times x minus 4 to the fifth. Well, I want to get a single log, so we don't want any number in front of it. So I'm going to take that 1/5 and put as our power. So we have natural log of x minus 2 to the third, x minus 4 to the fifth, all raised to the 1/5 power. Now when you got an exponent and everything inside your parentheses or brackets is multiplication, you can take everything to that power. So we can take the x minus 2 to the third power to the 1/5 power. So x minus 2 to the third raised to 1/5. And we can take x minus 4 to the fifth power raised to 1/5 power. Well, can't really do anything with this first bracket. So this 1/5 power we can just put as the fifth root of x minus 2 to the third. But over here, we're raising one exponent to another exponent. So you multiply the exponents. 5 times 1/5 gives you 1. So this becomes x minus 4. And you can put a bracket around it like that to indicate the natural log applies to both of them. And that's your answer. Let's look at number 14. We've got 3/5 bracket natural log of x minus 1 minus natural log of x plus 3 minus natural log of x minus 7. So we're going to do what's inside the brackets first. Well, our first log, log of x minus 1 minus log of x plus 3. Well, minus becomes division, so we're going to have natural log of x minus 1 over x plus 3 minus natural log of x minus 7. Well, now we have log of something minus log of something, and subtraction becomes division. Now notice in this division I put the x plus 3 down below. Well, we'll do the same thing here. So this becomes x minus 1 over x plus 3 times x minus 7. And we got a 3/5 out in front, so we're going to take that and put it as our power. So we'll have natural log of x minus 1 over x plus 3 times x minus 7, all raised to the 3/5 power. Probably isn't beneficial for us to put that in radical form, so I'll leave my answer like that. Let me save that page. And 3, there we go. I believe that that was the last problem. Yes, it was. So let me stop the recorders.